Welcome back. Today we're going to go over a few multiple choice questions regarding asymptotes and also infinite limits. So let's dive into the first one. What is the vertical asymptote of this function? So recall that the vertical asymptote or asymptotes would be any restrictions from the denominator that can't be canceled out with the numerator. So notice that in our denominator here we have x squared minus 4, and recall that that is equal to x minus 2 times x plus 2. So therefore, if x is either 2 or negative 2, we would have a 0 in our denominator, and that can't be canceled out with the numerator because the numerator we can't actually factor an x plus 2 or an x minus 2 out of it. And so therefore, C would be the right answer here. All right, let's try another one. All right, so here's the second one. It asks us to evaluate this infinity limit here. So one thing we need to do, the very first thing we should do whenever we evaluate an infinity limit, is we need to look for the highest degree in the numerator and the highest degree in the denominator. So highest degree in the numerator is degree 3, because notice we have an x cubed. Highest degree in the denominator is also 3. And so we can ignore the minus 2x, the plus 1, and the plus 4x squared, because those are not the highest degree terms, so they can be ignored for the purposes of this. So then what we do, if the degrees are the same, then we just look at the leading coefficients for each, which are 5 and 3, where 5 is the degree of the numerator or the leading coefficient for the numerator, 3 is the leading coefficient for denominator. And so therefore our final answer would just be B, which is 5 over 3. All right, so here's another one. This one asks which function has a horizontal asymptote at y is equal to 0. So what are the rules for horizontal asymptotes in general? If the degree of the numerator and degree of the denominator are the same, then we just take the coefficients, kind of like we did in the last example when we were finding that limit. If the degree of the numerator is higher, then there is no horizontal asymptote. And if the degree of the denominator is higher than the degree of the numerator, then there is a horizontal asymptote at y is equal to 0. So the question is, which one of these has a degree of the denominator that's higher than degree of the numerator? And that would be option C, right? Notice that for option C, we have x squared in the denominator and just x to the power 1 in the numerator. Whereas all the other ones, either it's the same in the cases of A and B, or in the case of D, it's that the degree of the denominator is higher than the degree of the numerator. So therefore, C is the only correct answer for this one. All right, this next one asks us to find the limit as x approaches 3 from the right of 2x over x minus 3. So a reminder that this little plus beside the 3, this means from the right. If they were asking us to find this limit as x approaches 3 in general, we could say, oh, well, that's an undefined form, because we would end up, if we do direct substitution, if we directly sub in 3, we get 2 times 3 over 3 minus 3, which is 6 over 0, and so that would be, of course, something that doesn't really make a lot of sense. So what we're going to do, since we want to know what's happening as we approach 3 from the right, I'm going to choose a number that's slightly higher than 3, something like maybe 3.001. So I'm going to plug in 3.001 into here. So then here we're going to get like something like 6.002 when we multiply that by 2. And then for our denominator, same thing, 3.001 minus 3, which will give me 0.001. And so as we get closer and closer, the numerator stays approximately the same, and the denominator shrinks. It gets smaller and smaller and smaller. And as the denominator gets smaller, what happens to this overall? Well, if the numerator stays essentially the same, it has very minimal change, and the denominator just gets smaller, 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 then the overall number just keeps getting bigger and bigger and bigger. And so therefore it's approaching positive infinity here. And so the answer would be C. All right, here's our last multiple choice question for today. It says, if the limit as x approaches infinity of f of x is equal to 4, then the graph of f of x has which of the following? Either a vertical asymptote at x equals 4, a horizontal asymptote at y equals 4, an oblique asymptote, or no asymptote. So the first answer can't be the right answer, and let's talk about why it can't be answer A. Let's say there was a vertical asymptote at x is equal to 4. that would mean that as the overall function is going to infinity, that x would approach 4, right? Like we would, if we had a horizontal, or sorry, a vertical asymptote rather, like this at 4, then perhaps the graph would be going like this up to 4, or like that down to 4, something like that, and approaching 4. However, it wouldn't be the case that as x approached infinity, f of x is equal to 4. No, it would be the case that as we approach 4, we end up with infinity. So this is kind of backwards for this one. The next one says a horizontal asymptote at y is equal to 4. Now this is a yes. This is actually, B is the correct answer, because let's think about it. If we had that asymptote at 4, then that means that we're going to be approaching, as we approach infinity, so as we go further and further and further to the right, we're also presumably getting closer and closer and closer to that line of 4, right? We're getting closer and closer to the asymptote. And so therefore, this absolutely would be the correct answer. The next one is an oblique asymptote. So that's where we have like a slanted asymptote, or an asymptote that isn't a strictly horizontal or strictly vertical line. And that's only going to occur when the function approaches a non-horizontal line. And that's going to require the degree of the numerator to be exactly 1 higher than the degree of the denominator in that particular situation. And then the part D says there's no asymptote. And so that isn't going to work. If we have a limit, an infinity limit, then we are going to absolutely have a horizontal asymptote in that case, right? It wouldn't be possible for this limit of x approaching infinity to be the case, and for this to equal 4 rather than equaling infinity or negative infinity itself, in the event that we didn't have an asymptote. If it's approaching a certain value, that implies to us there is an asymptote at that value. So saying there's no asymptote wouldn't quite be right either. All right, so now we're going to go ahead and get into the free response questions. This first one says, find all the vertical and horizontal asymptotes of the function. Okay, so first thing I'm going to do is let's first start with the horizontal asymptote, because there's not a lot of effort that's going to go into finding that, is kind of the nice thing. So for the horizontal asymptote, what I need to do is I need to compare the degree of the numerator and the degree of the denominator. And if the degree of the numerator is higher than the degree of the denominator, then there is no horizontal asymptote. If the degree of the denominator is higher, then there is one at y is equal to 0. And if the degrees are the same for numerator and denominator, then that means that the asymptote is where the coefficients are. So in this case, that third one is the correct option. Notice that both of these have x squared as their highest degree term, so they are the same degree. And recall that x squared is the same as like 1 times x squared. And so therefore the asymptote is at y is equal to 2 over 1, which is just the same as y equals 2. So that's my horizontal asymptote, and there's only that one, and so we're good to go. Okay, next thing we need to do is we need to find any vertical asymptotes. And so to do that, I need to know when the denominator will equal to 0 without canceling out with the numerator, because any factors that the denominator has that it shares in common with the numerator, that indicates that there's going to be a hole at that point, not a vertical asymptote. And so I'm going to factor the numerator and the denominator in order to find the answer. So let's start by factoring the denominator. That's a difference of squares, so it's just going to be x minus 3 times x plus 3. And then to factor the numerator, I'm going to multiply the a and c value, so a leading coefficient with the constant. So 2 times 3 gets me 6. And then negative 5 is just negative 5. And I need to find two numbers that multiply to 6 and add to negative 5. And those numbers are going to be negative 2 and negative 3. And so therefore, we're going to have 2x squared minus 2x minus 3x plus 3. So notice I just copied this exactly, except instead of minus 5x, I wrote negative 2x minus 3x, because that's the pairing that we're finding here. Then I'll factor by grouping. I'm going to group the first two together and common factor out everything I can from those first two. So that'll be giving me 2x times x minus 1. And then same thing for the second 2. I'm going to factor out everything I can from negative 3x and 3. And we're going to get negative 3 from there. So negative 3 times x minus 1. And what's that going to equal when I common factor out the x minus 1? We're going to get 2x minus 3. So we end up with x minus 1 times 2x minus 3. And so notice that we actually can't cancel out either of those with the denominator, that neither of those two factors is the same as the denominator. It was still important that we do that to see, because maybe there was, for all we knew, but there isn't, right? That wasn't the case. And so therefore, what are the vertical asymptotes? They are x equals 3 and x equals negative 3, because those are the two values that would make the denominator 0 without being able to be canceled with any of the factors in the numerator. And so that's it. Those are our results. All right, so this next one says to evaluate the following limits. In this case, because it's not multiple choice, I'll talk about the answer, but I'm also going to go through what steps you'd want to write down in order to get the full marks on your test. So here it asks us to evaluate this following limit. Now, right away, I notice right off the bat that the degree of the denominator is 3 and the degree of the numerator is 2. And whenever the degree of the denominator is is more than the degree of the numerator, that means the answer for something like this is just going to be 0. So already I know the answer I'm expecting to get is 0. However, if you're asked to write out the full steps, we don't just want to say it's equal to 0 and then call it a day. I want to show the steps for how we would prove that this must be the case. So what I'm going to do is I'm going to divide every single term in the numerator and the denominator by x cubed, because that is the highest, well, it's not the highest degree term, but that is the degree without the coefficient of that highest degree term. So I'm going to do that. I'm going to say 4x squared over x cubed plus, or I guess minus rather, 3x over x cubed plus 1 over x cubed over 2x cubed over x cubed plus 5x over x cubed. Oh, and I shouldn't forget to put my limit. I'm going to write limit as x approaches negative infinity. Okay. And then we can cancel a lot of the stuff out, because here we're going to get 4 over x minus 3 over x squared plus 1 over x cubed over 2 plus 5 over x squared. And then everything else goes to 0. Once we actually plug in, and I should write this here as well, once we actually have negative infinity here, what's 4 over negative infinity, or anything where negative infinity is that denominator? All of those are just going to go to 0. So we're going to have 0 minus 0 plus 0 over 2 plus 0. And that's going to be 0 over 2. And what's 0 over 2? It's just 0. And so the trick we used earlier was correct. We got that it was 0, but now here we've actually written out why it would be 0 and gone over it in a bit more details. All right, let's do part B. So part B asks about the limit as x approaches 2 from the left of x plus 1 over x minus 2. So if we use direct substitution, we get that 2 plus 1 over 2 minus 2 is equal to 3 over 0. And of course, this doesn't really make a lot of sense, so we can't actually use direct substitution. So what we'll do instead, since it's 2 from the left, is we're going to plug in a number that's very, very close to 2 without actually being 2. I'm going to directly substitute 1.999 to figure it out. So let's do that. 1.999 plus 1 over 1.999 minus 2. So that's going to be, in the numerator, that is going to be 2.999. So essentially very, very close to 3, very much approaching 3. And in the denominator, I'll get negative 0.001. And as I keep getting closer and closer to 2, I'm just going to get smaller and smaller. Well, I guess I'm going to have absolute values that are getting smaller and smaller, closer and closer to 0 in the denominator. And what happens as our denominator gets closer and closer to 0, the overall number gets bigger and bigger. Now, in this case, because we have a negative, it's going to become an even like bigger and bigger negative number, or I suppose I should say a smaller and smaller number, right? We're going to have a bigger numerical value there, but because everything's negative, it's going to be less, right? It's going to be further negative. And so, therefore, the answer here we're going to end up with is negative infinity. And so our answer for this one is negative infinity. All right, and here's one last one to round it out. It says determine whether this function has any horizontal asymptotes and justify your answer. Okay, so how do we know if it does or doesn't? If the degree of the numerator is greater than the degree of the denominator, then there are no horizontal asymptotes, which that is the case here, so that's what we'll write down. If the degrees were the same, then it would just be the coefficient, so there would be one in that scenario. And if the degree of the denominator was higher than the degree of the numerator, then there would be one because it would be at y is equal to 0. So I'm going to say no, there are no horizontal asymptotes. And why not? Because the degree of the numerator which is 3 is greater than the degree of the denominator, which is 2. And so there we go. As always, if you do have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.